to this video here where we're discussing how you can use certain mathematical formulations to understand the real estate market in a complicated city such as Mumbai or any other Indian city for that matter. We're going to use a couple of tools over here in this video. We're going to develop an AI-powered digital twin capable of modeling Mumbai's real estate ecosystem. And we're going to use tools such as machine learning, spatial analytics, XGBoost, neural networks, and graphical information systems. All right. Now, the heat kernel models how investment influence propagates through neighboring regions of Mumbai, providing a mathematical framework for understanding spatial investment dynamics within the urban property market. So I'm not going to venture too far here, but first, let's just understand what the heat equation is. So this is the heat kernel modeling, and it is this equation K that's a function of the position xy, and its argument is given as the exponential of negative d squared over 2 sigma squared. So d is the Euclidean distance of x comma y from the origin, so that would be d squared equals x squared plus y squared, and sigma controls the spread of influence. So this is a constant based on the heat kernel, the particular heat kernel that we're using, and of course k of xy is the resulting influence. So we're going to study how this equation can be used to model property prices in a city like Mumbai. We also have a little bit of Python code over here, and what we have over here is some simple is a simple graph really of this heat kernel for the value of sigma equal to 1, and we're going in the range between -4 and 4, as you can see over here. We're taking about 500 observation points, and then we just plot the heat kernel. It looks very much like a normal distribution. In fact, it is a normal distribution, and we'll see now what repercussions this has on the rest of our system. Thank you. Move another step forward now, and we start to look at this heat map. In fact, here we've created another visual for the heat kernel. So properties close to the center have larger values of K. So imagine this were a map of Mumbai, and here this red hotspot represents some particular point, say Bandra, and or maybe Santa Cruz. And then what happens is, as you go out further away from this hotspot, the property prices cool down, they get lower and lower, but near the hotspot the property prices are very high. That's essentially what we're trying to model using the heat equation. And while properties farther away experience a rapidly decreasing influence, that's essentially what we're talking about. And again, this is how we've graphed it using this line space function in -2 to 2, and we have z equal to negative x squared plus y squared over 2 sigma squared, for sigma equal to 0.4. This creates this heat map, in fact. Now, the whole idea here is this model is what we're going to use in a property valuation system. Here, actually, you can see we've created a website here where you upload a document of a property, and then what you get is you get as an output is an analysis of the property. In fact, you get an analysis of the property once you generate the investment report. Okay, so we're trying to actually use the heat kernel over here to create that analysis, part of it at least. And of course, as we mentioned earlier, we're using MATLAB, Python, Streamlit, XGBoost, neural networks, a lot of different things really. And the objective is to develop an AI-powered decision support platform capable of modeling Mumbai's real estate system. Of course, this then ultimately would be generalized to any other city as well. And we have a scoring framework where the investment score is the property price plus the rental yield. So the outcome of this, of course, would be to identify high potential investment zones, forecast market trends and property appreciation, analyze rental income opportunities, support strategic urban planning decisions, and visualize real estate dynamics through digital twin simulations. And of course, we'll get to this later on, a better mathematical model, in fact, that is even better than the heat kernel. Thank you for watching.